Okay, hello, I'll introduce myself. My name's Colin Jones. I'm a professor of climate science at the University of Leeds. I'm a member of the National Centre for Atmospheric Science, and I head the UKRI system modelling activity. And in TipESM, I lead Work Package 1 and model experiments.
My name is Torben Koegnik. I'm heading the Global Climate Modeling Group at the Swedish Meteorological and Hydrological Institute. And in TipESM, I'm leading Work Package 5 on linkages between extremes and tipping points and cascade load.
Are we running?
Yes.
Okay, I'll pull this one off. And the first question is, what are tipping points? So tipping points, they can happen in any system. They can happen in society. They can happen in many familiar walks of life, but they happen in the climate system as well. And they tend to be when a change happens in a particular part of the climate system. The ocean circulation could be an example, where there's a forcing of the system that makes it become unstable. And suddenly it flips to a completely new state very rapidly, much quicker than the typical timescale of that phenomena itself, the ocean as an example. And often when it's changed to this new state, even if you reverse what we call the forcing that has pushed it into that state, it doesn't necessarily come back to where it started from. And that's a signal of what we call irreversibility in the climate system. So the two key things, I think, are the change happens very rapidly compared to the timescale normally felt by that system, and it's not always reversible, even if everything else is reversed.
So, what are examples of climate tipping points? In the climate research, we often deal with 6 major tipping points, which are also called global tipping points, because they have an impact on the entire global climate system and then even further beyond on the ecosystem or society. And these 6 climate tipping points are first the large ice sheets on Greenland and Antarctica, which might melt, lead to a lot of sea level rise. These are the boreal forests, the tropical forests, which might die over time when it's getting very warm and drier. Then we have the permafrost in the northern land regions and the ocean circulation system in the North Atlantic, the AMOC, the Atlantic Meridional Overturning Circulation.
Okay,
Next one.
there I go. What may be some consequences if tipping points are what? If tipping points are exceeded. Okay, so we can give a couple of examples. So Torben referred to the Atlantic Meridional Overturning Circulation. So if that halted very rapidly, one of the major consequences would actually be a significant cooling over Europe, Northern Europe in particular, but Europe generally, with significant impacts, because we're talking about significant cooling. So it's believed that AMOC shutdowns in the past, not in the context of when we've had climate change as we do today, but in the past have led to very significant cold periods over Europe as a result of that shutdown. That would be one example. Another example would be if there's rapid dieback of the Amazon forest, it can self-amplify, so the whole regional climate over South America can change with significant drying out. And the Amazon forest is a significant sink for carbon from the atmosphere. So if there's a rapid dieback of the Amazon, then you can end up with more carbon remaining in the atmosphere due to human emissions rather than being taken up by the biosphere. So those would be 2 examples, there's many others.
So, next one. Oh, how might we know if we are approaching a tipping point? Because I think Colin would answer to that.
All right, so this one can get quite technical. So if we turn back to, say, the Atlantic overturning circulation again, that naturally varies. So even without effect of humans and things, you can have periods where the Atlantic Ocean is a little bit stronger in circulation and a little bit weaker in circulation. Often, but we call that variability. And when you approach a tipping point, quite often the natural variability begins to change, and the system loses what's called resilience. So as the system gets pushed a little bit away from where it wants to be, it finds it harder to get back to its natural state. So the variability of the natural system begins to change radically as you approach a tipping point. So that can be an early warning indicator that something unusual is about to happen and a rapid big change is about to happen as a consequence. So we tend to look at variability, and if that begins to change badly and strongly and systems begin to lose what we call resilience, then we think we are maybe approaching a tipping point.
How do you investigate tipping points in TipESM? So the main tools that we are using in TipESM are climate models, or even so-called Earth system models, which not only include the physical climate components like the ocean, the atmosphere, sea ice, but also more Earth system components like vegetation, chemistry in ocean or atmosphere. And what we are doing with these climate models is that we are running them for different climates into the future, and particularly we bring them up to different warming levels, global warming levels, warming above the pre-industrial value, for example, 2, 3, 4 degrees. And then we look into our simulations and in the data from the simulations using statistical methods to see if we identify tipping points and what tipping points would occur at what warming levels. Then we look what is happening before a tipping point occurs and what are the consequences after that. In addition, to better understand and investigate the consequences, we are doing so-called make it happen experiments, where we artificially introduce a tipping point into the climate model, and then we look what's happening afterwards. So we are using a little bit different strategy to both understand what is happening before, how the tipping points are linked to each other, and what are the consequences after. Why are tipping points important to understand? We already heard that there might be huge consequences when we reach a tipping point, both for the climate system as such, but also for the ecosystem or society. We know from many of the major tipping points that they have happened much earlier in the past and paleo periods back in time, but we still do not really know at what warming levels, what tipping points might happen, and what really are the exact consequences of passing these tipping points, and also not exactly at which time scale these tipping points or the consequences would happen. So it's very important to investigate that more, to understand it better, and to provide more information on the society.
Right.
I think Colin, you were starting off.
Oh, am I? Okay. Okay. So what do TipESM researchers do when they aren't working? And my first response to this was, well, do we ever not work? Well, of course we do. Yeah, we have periods when we don't work. So what do I do then? I guess this is directly at me. So fortunately, my kids are all grown up now, so I no longer have to run around chasing after kids, which I used to do when they were little. So now I have a bit of free time for myself. I'm a big football fan, so I'm a fan of Liverpool Football Club, and Liverpool, as you will well know, are top of the Premier League, top of the European Champions League. Shall I keep going? So I watch football. I'm a keen cyclist, so I do a lot of cycling. And connected to that cycling, there's a group of us that cycle. We often stop at the pub on the way home because we live in the UK and we like going to the pub. So cycling, pub, and football would be three things I do in my free time.
What languages do TipESM researchers speak? So TipESM researchers are from many countries in Europe, so they speak many different languages. I'm outside work, I'm speaking German and Swedish mainly, but the common language is English in TipESM, as in most research areas, and we are writing in English, all documents are in English, articles are in English, and so on. Then there are many other languages for programming, for example, but that might be Python. Well, some older guys use still Fortran 77, maybe. So a lot of different languages are used in TipESM.
When we talk amongst ourselves in the pub, we speak Klingon. What do TSM researchers enjoy about their work? Well, I think we all have a natural curiosity. That's why we're scientists. So we're fascinated by the climate system and by understanding it. And I particularly have always had a buzz, and I still get a buzz out of the fact that we can write down equations, solve those equations, and say something about how the world outside will evolve. I find that really cool. But I think we also enjoy it because we believe that we're doing something that is societally useful and relevant as well. It's important that we understand the climate system. It's important that we understand the risk around tipping points and the consequences. And ideally, it would be important that we had an early warning for them and that society would respond to what we are warning them about. So I think we enjoy what we're doing. We have freedom to work in the way we want and where we want because we have great colleagues. Our friends in TipESM from all over Europe would be a good example. And we think we're doing something that is worthwhile. So it's a nice combination.
What podcast do TipESM researchers recommend? Hopefully this one, but personally I'm normally not listening to too many podcasts. But recently there's one podcast I'm listening quite often to, and that's the podcast of Swedish radio on the USA. So quite interesting time to listen to that podcast. Unfortunately, it's on Swedish, so you need to speak Swedish. Otherwise, I can recommend it.
All right.
Good on, yeah. Okay. All right.